Hello and welcome to Maths with Jacob. This lesson will focus on problem solving, create a list. Sometimes there are multiple answers to a mathematics problem. The answers can be written down systematically so that all the possibilities can be seen. Try making a list. Example 1. Ted, Bob and Heck are taking part in a race. What are all the different finishing positions? Solution: if we write down all the possibilities, we have the following. Ted can come first, followed by Bob and Heck. Ted can come first and the other two come in a different order. Bob can win, followed by Ted and Heck. Bob can win and a different order for the other two. Heck can win, followed by Bob and Ted. Heck can also win, followed by a different order for the other two. So there are all the lists that we've written. And altogether there are 6 different finishing positions. Example 2. Mum and Dad have 2 children. Write down all the possible combinations of boy or girl. This is a very interesting way to do it. For the first child, assuming there are no twins, there's a possibility of a boy or a girl. Okay, so that's for the first child. If the first child was a boy, then the possibility for the second child is either boy or girl. However, the first child could have been a girl, which means the possibility for the second child is also a boy or a girl. So here are all the different possibilities. You start from the beginning. B, boy, boy. Start from the beginning. BG, boy, girl. Start from the beginning. GB, girl, boy. And start from the beginning. GG, which means girl, girl. So there are 4 different possibilities. These 2 here are different. They're not the same. Even though you have a boy and a girl, you can have the children in different orders. That's why they're not the same. Example 3. In the local tennis competition for girls, Sue, Mary, Jan and Kay play in a round robin. That is, they all play each other once. List all the games that take place. Here are the 4 girls with their initials, and I've written the 4 girls' names there and down here, and we're going to fill in these little rectangles here with their initials. Now, I want to fill in all the rectangles, even though some of these things do not take place. We're still going to fill in all the rectangles, and I'll explain to you in a moment why they don't take place. This square here, if you go up and then you go across, that's SS. This square here, up and across to the beginning, MS. This square here, up and across, JS, meaning Jan Sue. This square here, up and across, KS, meaning K Sue. I'll do one more here. This one here, if you go across, you go up there, then across, you got SM, Sue Mary, up and across, Mary Mary, up and across, Jan Mary, up and across, K Mary. And you do the same for these rectangles. Now immediately we can cross off these ones here. 1, 2, 3, 4, because the girls can't play each other. Okay, that just means K can't play K. It doesn't happen. That's why I've crossed those off. The reason I've got these red ones here is that we discard those. We do not take these into account because Mary playing Sue and Sue playing Mary, that's exactly the same. So they don't count. The same here. SJ, same as JS. They don't count. JM is the same as MJ. KS is the same as SK. MK is the same as KM. And JK is the same as KJ. So all those are crossed off. The only ones that are left are 1, 2, 3, 4, 5, 6. So the blue ones are the ones we take into account. Sorry, that shouldn't be crossed off there. The blue ones are the ones that we take into account. So altogether, from the table we can see that all the matches played were as follows: Mary Sue, Jan Sue, K Sue, Jan Mary, K Mary, and K Jan. So 6 possible matches. How many different outfits can you make with the following 3 pants and 2 shirts? Well, here are the 3 pants. There are the 2 shirts. If you put the 3 pants here, and each of those pants can have that shirt, which is this one. If you put the 3 pants down again, each of those pants can have that shirt. There they are there. So you can see there are 1, 2, 3, 4, 5, 6 different outfits. Okay, so there are all the possibilities. Example 5. A die is rolled and a coin is tossed in that order. List all the possible combinations that may happen. Here is a die, which is the singular for dice. Dice means 2 or more. When you throw one of these things, you can have all these different possibilities from 1 to 6. That's why I've got that there. After you throw this die, then you toss the coin. And you can have a possibility of a head or a tail. So if the first number was a 1 on the die, you can have head or tail for the coin. If the first number was a 2, you can have head or tail. If the first number was 3, you can have head or tail, and so on. Listing all the possibilities, you just start from the beginning and work your way up the tree. Pretend that's a tree that's fallen down, and these are all the branches. 1H. Go to the start. 1T. Go to the start. 2H. Go to the start. 2T. Start. 3H. Start. 3T. And keep going till you get all the possibilities. And you look down there, and there are 12 of them. So there's your list, 12 different possibilities. Example 6 is a little bit tricky, so let's have a look at it. Bill drew a table of all the numbers from 1 to 50. How many times was the number 4 written down? Read this carefully. How many times was the number 4 written down? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 times there. Here's another one, look. There's 11. See? 12, 13, 14, 15. So the number 4 was written down 15 times. And there's an example of how to solve problems by creating a list.